Chess, everybody. I think it's not something creative anymore. So a little bit about myself. I work at OpenTable. I am in the developer experience team. What we do a platform and tools for our engineers to have a better development experience. I really love open source. I'm kind of like active and try to contribute to many projects. And follow me on Twitter. I will share the links to the slides afterward there. But what I'm going to talk about today, it's about a story. And it's a story about refactoring and architecture and how we enable our team to move faster on a larger code base at a scale. I don't know how many reminds this movie. This is like, it's the never-ending story. It's a very old movie, but I feel that like every story that has to deal with refactoring and architecture, it's somehow kind of like a never-ending story. So I will tell you where we started from, where we are in the process. Of course, it's not a finished story. Before starting with the story, it's also good to get a little bit of the background, so I can give you a little bit of context. This will allow you to understand why it works for us, not necessarily it will work for you, and why we made certain decisions. So for the people that don't know OpenTable, it started almost 20 years ago in San Francisco and deal with restaurants registration. We provide a tool to restaurants and to diners. It's part of a bigger group. Maybe you know Booking.com, Kayak, and this kind of company. We're part with them in the Priceline group. What we do, we find a table. We find a table for quite a lot of people every month. We have like a 300 engineering department, and they're all scattered around various engineering offices. The headquarters in San Francisco, I work on the London engineering office. But that means that we need to coordinate very well. It's like every time you have like different offices, and it's like having a remote team. So it's like you need to coordinate. There are different time zones, and that's also something that play a role. We of course handling millions of requests per minute on our front end. So it's like the codes need to be able to handle the scale. And I would say that we have kind of like a full stack culture. What I mean by full stack culture, I mean that we like our teams to own the part of the application that they're building, meaning from the back to the front. They should be able to deploy totally independently as often as they can, possibly with continuous delivery. We want like them to be alerted if something for the part that they own of the application doesn't work, so they will be on call for that, and they will be the one that try to fix it when things goes wrong. So it's kind of like a full vertical ownership kind of culture. So every story starts with once upon a time. And our story starts with a monolith. And I think many stories out there start with the monolith. There are good parts like of the monoliths. Like a lot of people try to attach the word monolith with like a negative connotation to it. I think it's like there are good parts in monolithic application. Definitely like product consistency. It's very easy to get product consistency in a monolithic application. It's a little bit harder, and at least for us was like a little bit the problem to get the velocity. So it's like when we had a lot of teams, for example on OpenTable.com, we're like about 12 teams, 50 engineering working on that, and on different time zones. It was like a little bit hard to all have PR reviewings on different time zones. It's like don't be blocked by others. So the dependency were kind of like costly for us. A little thing about monolithic application. There are many types of what a monolithic application is. What I'm trying to refer here, it's like I'm really focusing on the front-end part, because if you think of even an architecture where you have microservices, the front-end very often still be run as a monolithic application itself. So I'm trying to concentrate on that part. Just to make a case, where we started with the monolith. It was like a .NET monolithic application. And so the first thing is like you need to break it apart. So what we did, we tried to create small teams, 2 to 4 people, that can own a very, very part, like a vertical slice of this monolithic application. You can think of in terms of kind of like root of our main applications. So for example, it's like we have like a star page, a restaurant profile page, a search page. Those are where all the part of our application, and with slightly smaller application. So that each team could handle all of this independently. The idea is like having minimal complexity, minimal dependency. It's easier to test, to maintain, to extend. And it kind of like worked for us. How that worked behind the scene, it's maybe also interesting. So if you look behind the scene a little bit, it's like what happened when you hit OpenTable.com and you look for the San Francisco restaurants. Well, first of all, you hit our load balance, and then we have a front door routing. And what this will do is like say, okay, actually what you want is like you want a microsite, that's how we call them, that start, that will handle this page, and the metro that you're looking for is in San Francisco. This, through our discovery services on our infrastructure, it's redirected to the requests to these sites. And these sites like have a very, very, very explicit API. You can say this is the domain, this is the metro, and what it will do, it will just return the page for them. So the user think of being always on the same site, but behind the scene it's like visiting multiple different sites. And one of those, and each of those is owned by a different team. So that's part of the story. It's like, wow, it worked great. It's like, this is like, it's good. We can move fast. We moved from a bi-weekly deploy of the monolithic application to 300 deploy per week. So the speed that we increased on that was like really, really big. But if you think about, and you think of all those sites, they all share some common parts. So the easier to think about are headers and footers. Like all of them, they have the same headers and footers. And this is like, it's where the story is like, you know, it's a little bit sad, and it's like it gets the bad parts. Doing changes to this part were hard, because it's like you need to do PR on different microsites, and because of like different time zone, you need to expect that those changes were live in different time frames. Also, for performance, issue was like that every site had to serve down all the assets. There was a lot of duplication assets, and what was good in the monolithic application, where we had like product consistency, it starts to be hard to maintain. It's like, you know, if every site has its own CSS to serve down, it's like having to keep that in sync with all the changes, it's what was harder. So one of the ideas that we had, it's like to try to fix this problem that kind of like we introduced with this new architecture, was like to create a microservice. And we say, well, maybe we can have a microservice that serve down those fragments. How that works behind, it's like, we thought it's like how we are going to redirect that to a microsite. Just for the sake of information, a microsite is a very, very, very boring stack. So it's like, you know, with mainly a lot of them, it's like Node, Express, and not much more. But because they are microsite and they are owned by the teams, like every team is it's allowed to build it as they prefer. So the microsite will do its own stuff. So it's like its own logic, maybe some query to some services, some database, prepare all the logic for the page to render. And I say, well, you know, I need a header, I need a footer. I don't really want to think about it. I don't have to care about how that it's all made. So I just do a GET request to get the header. I get HTML snippets, so CSS, whatever it's like it's needed for that. I can just appending to my response and send that back to that page. Of course, it's like you can even ask props for that. So it's like I want to have like the header for type admin. So it's like maybe it's logged in the user, or maybe you can even pass a accept language header if you want it in Japanese. I don't really the owner of the microsite, they really don't want to know how all that works. I just know that I need a header there to give me that, and then you get your page back. If you think about that, that is like it works well. It's like was like one of the good moments, like saying, wow, that seems to work fine. But of course, again, this new architecture introduced some new problems. For example, it's like one of the first one. It's like, oh, how do we handle changes? How do we handle breaking changes? It's like now we are just putting an header up, everybody is consuming. What if the version that we publish of the header has some breaking change and will break some microsites? So that was where, again, the story started to kind of like, have some bad parts. The other issue, it's like, it's also that it was, to address this, we created like an endpoint similar to NPM, so you can have semantic version on the endpoint of the components and just get the version that you want. This gives a little bit of contract for the consumers of the microsite, and they were in charge. They say, okay, I can pinpoint to a specific minor version, for example. The other problem is like was very hard to add new fragments, new components to these microservices, because this microservices was owned by a team. You need to do a PR on that. You need to redeploy the microservice itself. So it's like it was something that's like not that easy. And so we thought, well, maybe we can do something like serverless. Serverless in the sense of like it doesn't mean that you don't have operations, DevOps. It's like that the DevOps is kind of like hidden and built away in the service itself to help you out for that. We call that OpenComponents. And the architecture of that and how it works, it's something like that behind the scene. There are quite a few moving parts. First, like it's a CLI. So the CLI is like what the developers have to publish and create new components. So it can similar to the, for example, the Angular CLI, the create React app. It allows you to kind of like scaffold a new component, and similar to the NPM CLI, allow you to publish components on the registry. Then we have a registry. The registry, it's nothing more than like a REST API. Again, that allow you to publish components against. It allow you to consume and retrieve components from the registry. All of the consuming of those components, it's in runtime. And the component gets stored in a library, and if your components have static assets, they also get exposed to something like a CDN when you publish. Then we have like templates. Templates, it's the latest part of the platform, and it's something that allowed us to totally decouple how components are built. When we started, like we had very few templating engines like Handlebar and Jade. And now it's like you can create component with more complex UI framework like React or Vue or Angular. So how could we make it so that's like the whole platform and the whole infrastructure, it's totally agnostic on our team, so our part of the application is built. We have these templates that mainly they allow to compile and package your component when you're publishing it. So there is a part used by the CLI, and there is a part for that knows how to render and handle them, and that it's like used by the clients and the registry. Client library, we have quite a few more. I think we have it for Ruby, Rails, Sinatra also, and they mainly it's like our client that allow you to consume components. So you have like the simplest one to use is like it's a JavaScript client library. It's like about 2K, so kind of small. It allows you to put it in the browser and like just do client-side rendering of this component. And then you can have like a node library, for example, used by the microsite that we saw earlier. So how many are following how yes, okay. I don't know, because like I know there is lunch going, so probably many of you are starving. So I think it's good to maybe get like a little breakdown. It's like the phases of those architectures. Like the first step was like we kind of like slice at the monoliths in a microsite architecture. That was like kind of good. It allows us for all those points that I show you, like minimal complexity, minimal dependency. It was also good because at the time we introduced this, we were going through a redesign process, and so we were able to tackle this redesign by a route at a time and say, okay, we create a little team, it will handle this part of the application, and so on. We then tried to figure it out how to share the common parts for two slides, and this was like this microservice. And the third part was like, oh, how can we make that like as a self-service for people to kind of like just deploy components and consume components without having to think about the infrastructure behind. And the last part was like, how can we abstract how components are built? They're just, at the end, they're just immutable pieces of HTML, JavaScript, and CSS that they can run both on the server and on the client, as we will see. Also, something that's interesting is because every time you publish to the registry and each component is mutable, you can have like infinity cacheability. And so we can see some of that in a demo. I think it's like maybe a demo can give a little bit a more understanding of how that all works. So what you can do is like you can install a package from NPM. I already have it. If you run, it's like you will see that you have a lot of it's big enough to read. Okay. You have some commands. So what we can start is, for example, with the init command that's similar to the new commands in the ngCLI or the create React app. And then you can also, so it's like you pass it a name of the component that you want to create, and you can pass a template. So in this case, let's use the React template. So if we see what we have now components, and if we look inside, we have few files. Let's start from the manifest. So it's like if we look at the package.json, it's almost like something that you expect from a package.json. It's like nothing special with name, description, and version. And then we have like something very specific to OpenComponents. It's like define, for example, the files. So in this case, we have a scaffolding with a server. The server is like like a data provider. You can think of that similar to AWS Lambda. So it's like when you call this component, we can run this function in our infrastructure and have access to all the part of the private infrastructure. You can create your logic. You put your logic there. You create mainly your model, and you pass it to the view. And then the view it's just an entry point for the app and the type of that. Then you can have some parameters. Those are query params that the component can accept when you call them on their endpoints. The nice part is like that by specifying there in the manifest, we can get some server-side validation and some documentation out of the box. The dependency, it's like this is the part of the template that is being used by the CLI to compile it. The server, it's very simple. It's just an async function, and disclosure is being called whenever you ask for a component. And what it returns, you return your model. So in this case, we are taking out a query parameter called name, and we are passing that as model. In React world, this would be props or state. So like. And then we have our app. Simple React app. We're doing some CSS module here, and as you can see, we're using this props name that it's been passed. So what we can do now, we can start a local dev registry to see how that works. You run it with a dev command. So what you see, that's like we have now a registry app, and we have our component. If we go into our components, we can see some information. So it's like the documentation that I was talking to you about, the parameter, what they accept, and what is the default, and the href for the component, and you can have a preview. So for example, it's like, let's say that we want to change it, I don't know, something like that, then we're going to save it. So you can you have a live reflection, you can check the new components there. The same of course, it's true for everything like CSS, for example, in this case. And you can also have you can pass it params. So for example, we can say we have a name params, and we can say, oh, this is like content connect. And so you can pass that to your React application. The interesting part, it's like what we are seeing now, it's like it's all client-side rendering. So it's like what is happening here, it's like we're calling disclosure, we're creating our model, and we are passing on the client library that it's just fetching the data and the templates and rendering it to client. But what if you want to have like a server-side rendering? Well, that's like it's normally what happens when you just hit the endpoint of the component. So if we hit that point of the component, we get like a server-side rendering back. And you can see, for example, you put something that you can find easily. You can see that the foo is like it's been passed and rendered in the React tree, and also it's been passed down if you want to do rate rotation on the client. So now that we have our components, like you will say, okay, how do we, let's publish it. Let's publish it on a registry. First things that we need to do is like just add the registry that we want to publish. So I created a quick registry for this demo. Okay, and then you can just do publish, similar to NPM, very similar to NPM. Very complex password. Whoop. Okay, so we got an error, and it's like it's a good stuff. It's telling, well, you cannot publish this component because there is already a version 1.0 on the registry. So it's like components are immutable. You cannot override a version that already exists because that will break all the consumers that are actually using it. So what we can do, we can just say, well, I think I have up to 0.2. Let's do a minor with 3, and then let's just retry. Okay, so now our component is published on a live registry, and we can go and check it out. So this is like we see that's like it's 1.3. This is like the one, and it's purple, so it's like that's the one. Then I think it's like on the info you can also see all the various versions that have been run. So it's like if I go back and check one of the previous. You see this was like a previous component. All the logic also it's coupled to this. And this is in the interesting part. Normally when you have a part of the front end, it happens that if you want to iterate fast, sometimes you need to change some logic and some part of the backend or the API. In this way it's always coupled. So it's like when you do a publish of a new version, also the logic with it, it's like maintaining with that version. So I think we go back to the demo, to the slide. So now that we have this published, one thing that I can show you on the registry, I also have landing page. This, for example, is the site that we use. So the site for the project is also a OpenComponents, of course. And so it's like how can you consume this, and how can you insert this in a website. So client side, it's pretty easy. So it's like you can use a custom tag, and the custom tag that works for us is OC components, and you put the href and the version that you want against like the version supports semantic versioning. And then you add the script for the client, client-side rendering, and that's how you get it working. So for example, we have just an index HTML on GitHub pages, and that's just the 3 lines that we have there. And it's like, so every time we update it, we just bring out all our transactional emails. So it's like the teams can just continuously update part of the emails without having, and deploy totally independently without having to have a dependency on the team that's like maybe handle the rule sending out of the email, the infrastructure and stuff like that. And we have our own system for doing that. The other part that normally comes often to mind when you're doing something like that, it's like external widget. So every time you think that you're using maybe something like iframes, it's something that's being used a lot for this. It's something that's like you want people to embed on their website. You totally don't have control over their website, what is in there, and you want to be sure that you're able to update the version they are using for you. So it's like you can just lock into a major or something like that for them. So for example, we have a reservation widget that restaurants can embed in their restaurants' sites, so people can make reservation, and this is also served as an open component. So every time they deploy this widget to the registry, all the thousands and thousands of restaurants that we have, they get it automatically. Of course, when you start to build stuff, you need to build some tools around. So it's like one thing that we have, it's like it's a little Chrome extension that what allows you to do, it's like it's find all the components that you have running on a specific website. And for each of component, you can choose, for example, the version. You can totally change the parameters that it's accepting it. And these allow, for example, in this, we are changing the review components to Japanese. And as you will see, only that part of the site will render. And this is like a production site. So it's like the nice part that then you can do, you can say, I want to switch that component and fetch it from my local dev registry, the registry that we just fired up a couple of minutes ago in my demo. This allows you to have like your development version of the components being run inside your production environments, like production site, and see how that works. So who's using OpenComponents in production at the moment? It's like, of course, us, we created. We have Skyscanner, that's like, it's a company that deal with flight reservations. They're using Skyscanner, they're also using OpenComponent. And Check it's a big company in the States that deal with books for all the students in the US. And I took some code that I think this was interesting and give you a little bit why we like it and why it worked for us, this kind of architecture. So like, this was like, this is employees for us, and it was like, wow, it's like it took me really so little to kind of like deploy something in production with something that we have so many people working on it, and the system is quite complex at that scale. So this was like pretty cool. Similar approach, it's like also from Skyscanner. So it's like for that, they also break their monolithic architecture into smaller components, and they allow us, this architecture and this open source project allowed them to have ownership and keep moving faster. Same for Check. So before thank you and like maybe opening it up for live question, one thing that's like I wanted to kind of like ask, it's like maintaining an open source project, it's like it's very time consuming. So it's like even if you do that, it's like on your payday job, so it's like we are paid for that, it always goes way behind that. It's like, you know, it's like you need to be there to answer people during weekends, during the evening. So it's like, if you give us a star on GitHub, I will love you all. And I have stickers, of course, for everybody. Just come and talk. I think I don't know, with the time, it's like I try to make it not too long so you don't fall asleep before the food. I don't know if you have any question.
I can speak louder.
Okay, yeah.
Question. As I understand, you delivering components with it might be written in React, Angular, Vue, or etc. Example: we have 5 components on one page. We use React, one use Angular. How you deliver these vendor dependencies? Within components, or you have some shared layer, or how it works?
Good question. Thank you. So the template system, it's what handle all of those details. So for example, we see that we use the React template. The React template, when you're doing the bundle, handle all the vendors, and so it's like, and it knows with the platform and the infrastructure what to put on the CDN and serve it down. So it's like, for example, React DOM, and some of other vendors are not bundled in the bundle, so we don't serve it multiple times within a component. What is then able to orchestrate that? It's our client, JavaScript client. So for example, the JavaScript client knows, oh, on this page I have a React component, and this React component needs those kind of vendors, so I make sure that those are loaded before attempting to render that.
Thank you very much.